All right, now we're going to look at trig ratios. Now, 3 of these ratios you've already seen, but we're going to add 3 more because we've got 6 altogether. So it goes back to reviewing what you've already seen. You should be familiar with SOHCAHTOA, okay? And then the S, C, and T stands for sine, cosine, and tangent. And then the O is opposite, H is hypotenuse, and A is adjacent. All right, so now we have sine, cosine, and tangent, and we're going to add 3. And these 3 go along with sine, cosine, and tangent. So to go with sine, we have cosecant. To go with cosine, we have secant. And then tangent, we have cotangent. Okay, everything needs a co. So sine doesn't have a co, so it gets cosecant. Cosine already has a co, so it just gets regular secant. And then tangent gets cotangent. All right, now you have to remember what goes with what. To get from one to the other, so to get from sine to cosecant, we flip our fraction, right? So using SOHCAHTOA, we can fill out this top row here. We can say sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There's my SOHCAHTOA, and now I can use that to figure out cosecant, secant, and cotangent. So cosecant flips sine. So instead of being opposite over hypotenuse, it's going to be hypotenuse over opposite. And then secant flips cosine, so we have hypotenuse over adjacent. And then cotangent flips tangent, so we have adjacent over opposite. Right? They're actually reciprocal ratios. So now the opposite, adjacent, and hypotenuse, all comes from a right triangle. So if I have a right triangle and I pick an angle, so we'll put theta. Remember, theta is just a variable. It's just we use it for angles. All right? If I'm working with this angle up here, the opposite side is going to be the side that it does not touch. So that's going to be down here on the bottom. So this is the opposite side. Okay, adjacent is going to be the one that it does touch. Now, it touches 2 sides. It touches this vertical one here and the slanted one. But the slanted one is across from that right angle, which makes it the hypotenuse. The hypotenuse never changes. Regardless of which angle you're working with, the hypotenuse is always across from the right angle. All right, then that leaves this other side that the angle touches as our, adjacent side. All right, so it's all about the triangle and working with an angle right now in terms of getting our ratios. All right, so for example, we've got to just find the 6 ratios for the angle A below. All right, so for starters, I'm only given 2 sides of this right triangle. So the first thing we got to do is find the missing side. All right, so now my hypotenuse is over here, so that means this is my C value. So we'll call my missing side A. Could be A, could be B. And I'm going to use Pythagorean theorem. So we're going to say A squared plus 8 squared equals 17 squared. All right, A squared plus 64 equals 289. And then A squared equals 225. Square root it, and we get A equals 15. So now we have all 3 sides of our triangle. I want to find my 6 ratios for angle A. Right, so that means everything I do, everything I find is going to be coming from this angle up here. So from that angle, it's just like this triangle up here. The bottom is my opposite. The 15 over here is my adjacent, and 17 is my hypotenuse. So now I'm just going to write out my ratios. So we'll start with the ones you remember. Okay, sine of theta is going to be opposite over hypotenuse. So my opposite side is 8, hypotenuse is 17. I can't simplify that at all, so I leave it. That's it. Cosine is adjacent over hypotenuse. So that one's 15 over 17. All right, and then tangent of theta, right, is opposite 8 over adjacent 15. And again, make sure you simplify your ratios. All right, but none of these can be simplified. All right, now to go with sine, we have cosecant, which we use CSC. And all we do is flip sine. So that's 17 over 8. Cosine goes with secant, and we flip cosine. So that's 17 over 15. And then tangent goes with cotangent. So that's 15 over 8. Okay, so now the questions you have aren't going to ask you for all 6. They're going to ask you for one in particular, right? So you can think of SOHCAHTOA, and usually the easier option is to find sine, cosine, tangent, right, regardless of which one you're asking for. And then if you're asking for one of the new functions, flip the one that you started with. So like if it was asking for secant, find cosine and then flip it to get secant. All right, so you got sine, cosine, tangent, cosecant, secant, and cotangent.